Okay guys, so the last video ran long. I just had to make a separate video to wrap this up. So multiplying fractions, dividing fractions, adding and subtracting fractions, and some of these we have to change to improper before we even do that stuff. So on that note, multiplying fractions is the most straightforward of all these skills. So for multiplying fractions, all I have to do is multiply straight across. In the note sheet, the one that says skills for fractions or strategies for fractions, this skill for multiplying is just called oh so easy, because all you do is multiply straight across. So this one, 2 times 9 is 18. By the way, if you notice, it is a negative fraction times a negative fraction, so my answer is going to be positive, because even though they're fractions, it's still negative number times a negative number equals a positive number. 3 times 4 is 12. And I like leaving my fractions as fractions, improper or not. Like, I don't change them to decimals, but I do reduce. So divide by 6, right? 18 divided by 6 is 3. 12 divided by 6 is 2. 3 halves, 3 divided by 2, aka 1.5 or 1.5. These right here, I'm not going to be able to show all the work, but remember to change this to an improper fraction is we make that little loop from the bottom to the top. We multiply, we add. 3 times 3 is 9. 9 plus 2 is 11. So this first fraction is 11 thirds. If you heard that right now, it's my cat going crazy on the chair I'm on. And then we're going to multiply, right? 1 times 4 is 4. 4 plus 1 is 5. So this one's 5/4. And now I'm ready to do this. 11 times 5 is 55. And we just multiply straight across the top and then straight across the bottom. So 3 times 4 is 12, and pretty sure that's not reducible. Another reason I know it's not reducible is because if you try to cross cancel here, you can't. 5 and 3, no common factors. 11 and 4, no common factors. So if there's no common factors when you try to cross cancel, when you multiply, that should be fully reduced already. Next one is dividing fractions. So you may remember this, but when you divide fractions, the first one, negative 3/5 here, doesn't change. I do have to change the division to multiplication. And so instead of dividing by 7/11, if I multiply by the reciprocal, that would be the same thing as dividing by 7/11. So instead of dividing by 7/11, I'm going to multiply by 11/7, and that would be the same as dividing. So I do have a negative number times a positive number. That is going to be negative. By the way, the strategy is called, for dividing fractions, ollie kickflip, and an ollie is a skateboarding term, and so is kickflip. The ollie is because I'm ollieing or jumping over the first fraction. The kick is I'm going to kick the sign and make it multiplication, and then the flip is because I flip the second fraction. So if you look at the note sheet for strategies with fractions, ollie kickflip is used for dividing fractions, and it's ollie because you jump over the first one. And kick means kick the sign and make it multiplication, and the flip is you flip the second one. So ollie kick flip is used for dividing fractions. Once I do that, though, dang it, that's no good. Once I do that, my problem does become multiplying fractions. So anytime I'm dividing two fractions, it always becomes multiplying two fractions. So negative number times a positive number will give me a negative answer. 3 times 11 is 33. And 5 times 7 is 35. And that's it. Negative 33/35 is my answer. And not reducible, so we're just going to let that be. Keep in mind, guys, you can rewind and fast forward as needed. So I'm off to these next ones. Change these to improper. 4 times 4 is 16. 16 plus 3 is 19. So 19/4. And I am going to skip a step here. So 2 times 1 is 2, and 2 plus 1 is 3. 3/2. but I want to flip that, right? Because I'm going to, remember, jump over the first fraction, ollie, kick the sign, make a multiplication, and then flip. Ollie, kick, flip. Jump over the first, kick the sign, make a multiplication, and flip this. But I can't flip it till I change it to a mixed number. So again, it's 1 times 2 is 2, plus 1 is 3. So this is 3 over 2. But once I change it to multiplication, I got to flip 3 over 2 and get 2 over 3. So hopefully you're okay with that. And now I'm just ready to multiply across, and my life will be a little easier at the end if I cross cancel here. 2 and 4 I can divide by 2. 2 divided by 2 is 1. 4 divided by 2 is 2. And again, by cross canceling, initially I eliminate the need for reducing at the end. Multiply straight across. 19 times 1, that's 19. And 2 times 3 is 6. And I'm done. 19/6. The next one is, this is the method for adding and subtracting fractions, was called diamond method, so I'll do my best to show that here. First of all, 4 times 5 is 20, 20 plus 1 is 21, so let me make that into an improper fraction. You don't have to do this, but I'm going to go ahead and do this. I feel like it's a little more reasonable to do it this way instead of dealing with the numbers out front and the fractions. So again, this one's 21/4. Minus minus will become plus, so I'll go ahead and account for that now. And then 2 times 4 is 8, and 8 plus 3 is 11. Remember, I already took care of the 2 minus signs. It's a plus sign, so I don't need to worry about my signs anymore. So that one's 11/4. Luckily, they both have a common denominator. Remember, I wouldn't be able to do this if I didn't have a common denominator. So diamond method that I mentioned earlier for adding and subtracting fractions is, I only need it if I don't have a common denominator. So since I do have a common denominator, I can roll with this. 21 plus 11 is 32, huh? 32. Oh shoot, I messed up. Let me just cross this out so I don't have to erase everything. I converted this and I forgot it's negative, so sorry about that. So anyhow, it's negative 21 plus 11, which completely changes my answer. Negative 21 plus 11 should give me a negative 10, and then the denominator doesn't change, so negative 10/4, and that is reducible, right? Divide by 2, negative 5/2, aka 2.5, aka 2.5. But again, I just leave my fractions unless it's like a word problem and it's asking me, like, you know, how many minutes or something, then I'll change this to the number I need. But if it's just arithmetic math, I'll leave it. So here you can get a quick look at diamond method. These numbers are pretty large, so it's going to be a little bit of a large number, but either way, diamond method is this. You multiply here to get 1 times 24, and that number becomes your numerator in the first fraction, like your new numerator, where you'll have a common denominator. Remember, if you don't have a common denominator, that's what diamond method works for. My second step is multiply the 7 times the 15. That was a minus sign in there, so don't forget that. 7 times 15 is 105. And then my third step here is this is where the diamond method makes sense, because if you multiply 15 times 24, you see it creates this little diamond, and so that was the trick there. And then 15 times 24, let's see what that is. 15 times 24 is 360, so my new denominator is 360. By the way, when you create the final piece to get the diamond, the multiplying the two denominators gives you that number you need for a common denominator. This time it was 360. Now you might say there might have been a lower, right? That may not be the least common multiple, but nonetheless, diamond method gives you an option for doing this. So now that I have a common denominator, I just need to do 24 minus 105. So use a calculator as needed, guys. 24 minus 105. Let's see, let me think about that. 24 minus 105. Let's use a calculator. It's negative 81. So I have negative 81. That is supposed to be an 8. Sorry about that. But either way, negative 81 over 360. And I'm going to go ahead and leave that alone. It actually, you know what? I do know a little bit about these numbers. It is reducible, but like I know I can divide this by 9. I know this can divide by 9. So sometimes there is numbers you're familiar with where you can reduce. So again, you might know or realize that you can divide this by 9. If you cover up the 0, 36 can be divided by 9. So I guess technically if you divide by 9, right? Let's see what that would give me. 81 divided by 9 is 9. And 360 divided by 9 is, well, 36 divided by 9 is 4. So 360 divided by 9 has to be 40. So negative 9/40ths is a same value but reduced. So there's that one. And let's just do the last couple. Alright guys, so these right here, I feel like they're just a little complicated. I just want to use a proportion to do it. If you look in the book does it a little different, but similar. So anyhow, this is what I say. I say set up a proportion where you set up something like each dozen over the amount of sugar. So like, I'm just going to do this. So I'd set up something like 5 dozens requires, and this is like a compound fraction, so try to not let me confuse you. So basically I'm setting up a compound fraction because I have a fraction inside of a fraction. So anyhow, it represents that 5 dozen cookies requires 3/4 of a cup of sugar, and that would, just as far as the sugar being proportional, I can use that to figure out how much sugar is needed for 8 dozen cookies. So again, what I set up here was dozens of cookies over the amount of sugar. So 8 dozens over, I don't know how much sugar I need. I'm just going to call it X, right? So again, 5 dozens requires 3/4 of a cup of sugar. And 8 dozen would require X amount, right? I can use this proportion to figure that out. And in proportions, I like to just multiply diagonally, which is aka cross multiplying to solve. So I cross multiply, I get 5x, right? Those are called cross products, just in case you forgot, because I know you've seen this before. And then when I multiply 8 times 3/4, remember this is basically like 8 over 1. So this is what you'd get. You get 8 times 3, that's 24. But then you would divide by 4. Well, 24 divided by 4 is 6. So I'm doing a little bit of mental math here. Hopefully you're okay with that. Again, 8 times 3/4, I'd end up with 6. So once I'm here, 5x equals 6. I can divide by 5 to get my variable isolated. And according to this, I would need 6/5 cups of sugar for 8 dozen cookies, aka 1 1/5, aka 1.2. So 6. I'm just gonna put cups, guys. If I had a little better writing utensil, I might put cups of sugar for 8 dozen cookies, but I'm just going to put cups for this. 6/5 cups of sugar, 1 1/5 cups for 8 dozen cookies. And then this last one, let's see, chocolate chip cookie, 5 dozen requires 2 eggs. If you want to make 7 dozen cookies, exactly how many eggs are needed? Now round your answer to a realistic number that does not involve fractional parts of an egg. Okay, let's do this. Remember, set it up as a proportion kind of just makes the most sense to me, that 5 dozen cookies requires 2 eggs. So again, I'm using this concept of dozens over eggs, or this was dozens of cookies over sugar, now it's dozens of cookies over how many eggs. And I want to make 7 dozen cookies. Well, how many eggs does that require, right? So I'm gonna put an X again for my unknown. So again, cross multiply, 5 times x, 7 times 2, and those are your cross products. You set your cross products equal, so 5 times x is 5x, and 7 times 2 is 14. And if I just, if I just divide here, 14 divided by 5, right, I can get my answer. 14 divided by 5 is, it's not quite